Hello everyone, welcome to my channel. In this video we will try to understand the important name reaction, that is JULIA olefination, and the question is also asked from this topic and in CSIR December 2016 for 4 marks, and also came in various competitive exams like GATE, TIFR, etc. Okay, so now before starting to solve this question, we have to know how the JULIA olefination works and how the reaction proceed and what is the mechanism of this overall reaction. So let's see. And before that, we are stating the question. The question is a major product in the following reaction is. You have given a substrate like this and these two the substrate, and you have given a reagent that is NaHMDS. So what is this NaHMDS? So NaH is nothing but, I am writing here, NaHMDS. That is, it is nothing but sodium hexamethyl silyl azide. This is the overall name of this compound, sodium hexamethyl silyl azide. Okay, so what is the structure of this type of reagent and how it works? The structure of this compound is and here is a negative charge, there is a competitive salt sodium plus, and now you see there the negative charge over the nitrogen atom, and it's very much it can abstract the proton where the proton is acidic, so it will the negative charge abstract the proton. Okay, so it acts as a strong basis. So here is the work of the sodium hexamethyl disilyl azide. Okay, now see JULIA olefination. The name reaction is JULIA olefination reaction. So the JULIA olefination is this is the name reaction, that is JULIA olefination. Okay, now okay, so JULIA olefination, you have to know that the JULIA olefination is very much stereoselective reaction. Okay, so what is stereoselective? That stereoselective means it is a stereoselective reaction. Okay, so what is stereoselective? Stereoselective means that is it always form E-alkene. Okay, so E-alkene. So E-alkene means always it will form always the trans-alkene. Okay. Now see. Okay, a mistake. There is a mistake, that is sodium hexamethyl disilyl azide. Okay, there is a di, this two disilyl azide. Okay, so now let's move on to the mechanism. Now I am writing a structure like this. The R, the mechanism. Okay, this is here some mechanism. Now see, here's a structure given. I am writing this here, SO2PH. Is the R1 and R2. Now here I have given this reagent, sodium with a hydrogen amalgam and methanol. Now say methanol, how the reaction proceed? The reaction proceed, this methanol, I writing this here as this way, OMe minus, it will abstract the proton from here, and this bond go here, and this will leave from the system as a leaving group. And now see, this is the acetyl OAC type or acetyl type leaving group, so it will easily remove from the system. Now here there is a hydrogen. Now this is hydrogen R1. Now there is a formation of double bond. This is R1, this is hydrogen, and there is R2, and now here is this SO2, I am writing this SO2 like this. Okay, now you have given sodium. So sodium, it always follow the single electron transfer mechanism, that is set mechanism. So it allows to donate only single electron to this system, to any given system. So this sodium will leave an electron. The sodium will leave electron like this, and this will attack. I am writing this in a single head arrow just because this is a one. These two arrow represent that it has a 2 electron, but when the single arrow represent, that means there is only 1 electron donate. So there is only 1 electron donate. Now after that there is a formation of this compound like this, and S double bond O. Here is oxygen, so negative, and this bond breaks like this. So after that there is a negative charge, and there is formation of radical, and there is R2, and then there is also electron, where single electron is present, that's from sodium. So it will attack on the, so there is a sodium plus complex, and after that there is a removal of this bond, that is this bond will break like this way. So if the bond breaks like this way, so here is already presence a radical, and here is a formation also a radical. So here is a negative charge over the sulfur atom, and then there is a formation of this compound like this, and there is a formation of radical, and from the system there is this group of leaves from the system. So pH, this overall system leaves from the system. Okay, now there is a formation of radical, and after that you're in the given system there is already presence a sodium, so it allows to donate only 1 single electron, and then there is a hydrogen and R2, and here is a negative charge. And after that you have given this methanol. So methanol, from this negative charge, it can protonate 1 hydrogen from methanol. See, so this is the overall mechanism of Julia olefination. Now how you can identify that this is a Julia olefination reaction. So this is one type of condition, and in the question there is also given another type of condition. So I am discussing here there is only one type, and after that we also discuss this type of structure and this type of questions. Now there is a formation of, now see, this R group and this R group are trans to each other, that is there is a formation of E alkene, and that is why this is called stereo selective reaction. Okay, so and now see, now there is another question, that is how I am writing this structure this way, and how to get this type of structure. Now in the question you have given the structure like this, SO2 pH. Now in the and you have given a strong base like butyl lithium. There is a strong base like butyl lithium. Okay, now there is an acidic proton here. So there is a formation of negative charge, and you have given a aldehyde like this. So what it can do, this negative charge attack on this hydrogen, I'm writing this way, attack, and this one, and after that SO2 pH, there is OH, this type of structure, and after that you have given this Me SO2Cl. Okay, now what is the structure? Now the structure is like that. It's double bond O, there is Me and Cl. Now this oxygen has a lone pair of electron, it can attack on the sulfur atom, there is a breaking of this bond and this bond go back and the cell is leaves from the system. So after that I have given SO2 pH, this, and this is, I am writing this structure in short, this OMS. This is called methyl group. So from this structure we will get the methyl group. So this OMS, this methylate group is a very good living group. So here you can also see that this is also a living group. From here this is also a living group, and these two are trans to each other, and this in the presence of sodium hydrochirum and ethanol, this is as a solvent. It has a proton source of this reaction. There is a formation of this type of, there is a one, two, this one. Okay, so here is the final product, and these two are trans, this is the E alkene. Okay, now let's move on to the question. Now there is also given this type of structure, there is a big ring here, and there is also given a aldehyde. Now you can easily identify this is a JULIA olefination reaction, and there is another method and another type of mechanism, but there is in the question there is no only given the base but not given the this type of sodium hydrochirum like things. So okay, so there is another type of mechanism I will discuss here. Okay, now take the compound first. This is your compound, this is your compound. 6 Me. It's a very much bigger compound. Okay, so this is your compound, and you have given a NaH MDS. I have discussed previously that this is what is the role of this sodium hexamethyl diacylazide. This is a strong base, and there is an acidic proton, only acidic proton here. So this group abstract the proton. I am writing this way, abstraction of proton from this side, and after that this negative charge will attack on this aldehyde. So I am writing easily here for you that this way. Okay, these two groups are in same site, so you have to write these two groups are in same site. So CH2 OTS TES. Now what is OTS? In the question also it is mentioned that what is TES. TES is nothing but triethylsilyl group. Okay, so it is also silicon based compound, and this negative, and okay, here is also a given part, that is this one. So negative charge attack on this carbon and carbonyl, and this oxygen is a negative over the nitrogen, and after that there is a formation of this one as this double bond O, there is a negative charge, and this is a carbon CH O minus, and the overall group, that is CH. Okay, there is a compound, and here is a negative charge, and this is nitrogen and pH. Okay, this is the overall compound. Now this negative charge attack on this nitrogen, and here is the negative charge over the nitrogen atom. Okay, I am not writing this overall structure, I am writing this part only now. This not either then this video is much more longer, so this one is the structure. It's a negative charge on this system nitrogen. Sorry, that's pH, CH, TS, this. Okay, now this negative charge bond backs here, and this bond goes here, and this on the sulfur, and this bond backs here, and this is for here. This is the overall process, and after this process there is a formation of E-alkene. You have to keep in your mind that there is a formation of E-alkene. Now then there is a product. Sorry, this is below bond. Here is a methyl, there's a double bond missing. Okay, now this there is a formation of E-alkene, so you have to keep in your mind that there is a formation of E-alkene. Okay, now see, this is your final product. This is your final product. Okay, now let's move on to the question and find your answer. That there is a given, that is this one. Here is a formation of E-alkene. This is E, and there is a formation of Z-alkene just because of these two are within same side, so it is Z. And there is also E-alkene, but these two groups are not in the same. These two groups are different just because you have given this structure, this OTS, and these two are in same side, so there is a one bond away. It's okay, so this is not your answer. There is also E, and here is also E. Now you can easily find your answer. Now see, this is your E, and there is a formation of this two bond and this two double bond, and now check, there is a E, and these two are in same side. In the product you have already get that these two are in same side. Now this is your correct answer. So option C is the correct answer. So see, there is a overall mechanism and how to solve this question I am writing elaborately. And now for the further reference, you can study Carothers and Claydon, and there is a consequence reaction also that is called Ramberg-Buckland reaction. I am writing here Ramberg-Buckland reaction. This is also a very good name reaction. So we will discuss on this topic in another video. So I hope this video is useful for you, and please subscribe my channel if you want. And there is another announcement that if you want to know any other topic from organic chemistry, then also comment below on this video. And thank you for watching. See you in tomorrow. Till then, goodbye.